Now let's use this procedure we just talked about and we will solve some more problems. Okay, given this situation where we have AB sliding through this slider at a velocity of 10 to the left with an acceleration of 16 meters per second squared to the right, let's find our angular velocity and acceleration of CD, this link CD, 300 millimeter link CD. And we want to do this when theta equals 60 degrees. So let's draw some geometry here. So this is point D, and this is my link. Yeah, what a funny looking link. C. So along the line of action here, D is along the line of action of our piston. Let us create then our X value here, moving in this direction. And in fact, I have to draw this even bigger because this piston can articulate more further than what I originally drew. So let's put in then, this is our X here. And of course we'll have then theta in this direction here. And since this is a similar triangle, I can make life easy for me and cut this in half. So here I will then decide that x over 2 over 0.3 equals cosine of theta, relating theta to this x, and that means that x equals 0.6 cosine theta. And there we go. So now I can differentiate this for my velocity and get x dot equals minus 0.6 sine of theta. Theta is a function of time, so I have to use a chain rule on it. Theta dot. And theta dot is just our angular velocity. So let's solve for angular velocity now. So I end up here with 10 equals, now this 10 is headed in the same direction, so that's good. So 10 equals minus 0.6 sine of theta, and for theta I have 60 degrees times omega. So I can solve for omega, and omega equals minus 19.2 rads per second. This is the same thing as 19.2 rads per second in this direction. And I see what I've done here is drawn this in a direction I didn't really want to. I wanted to draw it this way, actually. So I always start from this line and draw it. And that puts my direction this way for my angular velocity. So acceleration next, x double dot, second derivative of this equals minus 0.6 cosine of theta, theta dot again, and then we need to take this and multiply it by the theta dot as we do our product rule, minus 0.6 sine of theta times, then the derivative of theta dot is theta double dot. So I'll rewrite my equation and then stick in values. So here we're going opposite direction. Acceleration is opposite direction of our x. So we're going to go with a minus here, and then cosine of 60 degrees, and then we'll put in. Now I got to use the negative sign that I've defined up here for the calculation. Minus 19.245 is really what this was 19.245. And this is 60. So now I can get alpha equal to minus 183 rads per second squared equals 183 rads per second squared in this direction. And there we go. Okay, this is book example 16.5. You have a window here that is being opened by a hydraulic lever, and this thing has a velocity of 0.5 meters per second, and it's constant velocity. And we want to find out at 30 degrees what the angular velocity and angular acceleration of this OB is. So let's decide here how we're going to set this up. I think so. This is our direction of motion. Let us go with this as x, because this connects with our body here, and this is stationary point. Then we have here as our theta. It's a nice little triangle. So that triangle, this is 1 meter in length. This is 2 meters here. This is some x value. Okay, so at the instant in question, then we have, it looks like an unusual triangle. We'll just use law of cosines. So x squared equals one side squared plus the other side squared minus 2 times the one length times the other length times the cosine of theta. It's a good equation to memorize. And this can reduce to x squared equals 5 minus 4 cosine theta as our relationship. So let's start taking derivatives here. So for our velocity, then we have the derivative. Now, one of the reasons I want to do this is because you have to use implicit differentiation, which means we take the derivative with respect to time of x squared plus our equals, then the derivative of the other side, or f of theta I'll just put here. So this is going to be, derivative of this is 2x times x dot equals, so I had to use a chain rule there, equals 5 drops out, we got minus 4. Cosine derivatives, we'll turn this into plus 4 sine of theta, and then that's a function of time too, so we have to chain rule that too. Theta dot. So I can simplify this to x dot equals 2 sine of theta, theta dot. So we have theta, which is 30 degrees, and we have our velocity, x dot. We want our angular velocity here. So we're missing x, so we have to figure out a way to get x. Well, we can get x just from the geometry. So x equals, so we got x squared essentially equals 5 minus 4 cosine theta equals 5 minus 4 times 1/2, because cosine of 30 is 1/2. Nope, I'm wrong. That's the sine of 30. So 5 times 4 times cosine of 30. So we end up with x equals 1.239 meters. Let's plug that into the equation up above and solve for omega, which is theta dot. So we get this relationship. Notice that sine of 30 is 1/2 and 2 is cancel out. So we get omega equals this. And that means that omega equals 0.620 and no change in direction. Looks like our boxes around our answers have a little bit of omega to them. Okay, let's do the velocity or acceleration. So we're going to take the acceleration of this equation here. So product rule here. So we've got x dot plus x times x double dot. So we're taking the derivative of both sides. So derivative of this side, derivative of the other side is minus 2 cosine of theta theta dot, and then we have an additional theta dot. Except we don't have no minus, because derivative of the sign is just positive. And this theta dot came because of the chain rule. And then we have the other function, which is 2 sine of theta times the derivative of theta dot is theta double dot. And that theta double dot is what we're looking for, the angular acceleration. We have all the other terms solved for or given, so we can just plug them in. Notice here that our acceleration is equal to 0 since we have constant velocity. So this relationship will be velocity squared equals 2 cosine of theta times omega squared, all this so far, plus 2 sine of theta. Again, this will be 30, and this will be 30, times alpha. And for our velocity squared, we'll just stick in the 0.5 squared and solve for alpha. So now alpha, if you do the calculations, equals a negative 0.415, which means that alpha is 0.415 in the opposite direction. And that's it.